Good morning. Welcome to the Smart Cities Marketplace webinar on navigating hydrogen integration in smart cities. My name is Ilko Kruisinga, and as you can see from my background, I'm with DNV, Ditnosque Veritas, and Ditnosque Veritas is a partner for a long time already in the Smart Cities Marketplace consortium that is working for DG Energy of the European Commission. And my role, I wear actually many hats in the Smart Cities Marketplace team. I do some matchmaking. I'm responsible for some knowledge management, and I also am responsible for the whole web infrastructure of the Smart Cities Marketplace. And it's my honor to be the host of this webinar with you today for the next 2 hours or so. I'll start off with an introduction of the agenda. So next slide, please. Thank you. So we have set aside 2 hours for this, with towards the end like 15 minutes or so of questions and answers. And so I do invite all of you in the audience to prepare your questions for the last bit of this webinar. So we have actually three groups of speakers. So we have a block that is being prepared by my colleagues Jochem Dauma and Malte Rens, who are consultants within DNV's hydrogen team. So they will set us up with some basic introduction of what is hydrogen, what is the hydrogen value chain, and what role does it actually play in the energy system, both in the built environment as well as in the industry and mobility. Provide some updates and insights into the market status and some key insights and developments in industry and mobility. And then we will move into some practical lessons that we as DNV have been drawing from let's say, project experience. So that might be really helpful for you working in cities, preparing your own hydrogen projects. Then we have a little case study, actually. We have a guest from Poland, from the city of Bydgoszcz, telling about their plans in introducing hydrogen in their city energy system. And then we'll move to the financial side of things. So we have a presentation on the financing and funding options for hydrogen projects, and how the Smart Cities Marketplace can actually help cities in achieving the financial closure on these projects. That section of the webinar will be dealt with by Tommaso Busso, who is also a partner in the Smart Cities Marketplace consortium. And as said, we then have set aside 15 minutes for questions, and I will be leading the discussion on that towards the very end. But before we move into the actual hydrogen content, I just want to provide you with a little introduction. What is actually the Smart Cities Marketplace, and what does it do, and how can it help you? So a couple of slides on that, and I want to focus on what is called the so-called matchmaking services, because I think that might be really relevant in this particular case. Next slide, please. So what is it actually, the Smart Cities Marketplace? So what it does, it is actually a resource for cities, for businesses, as well as for investors. So what it does, it supports and accelerates the identification of smart city projects to develop or invest into. So if you're a city official and you're looking to develop a smart city project, you can turn to us. But also if you're an investor and you're looking for a project to invest in, you can also turn to us. And we're also helping with the replication of scale up of embryonical pilot initial projects in your city as well. So that's one thing, and I will tell a little bit later on that shortly. And then the second bit is that we also have, you could call us a knowledge bank or a knowledge base on all kinds of information related to smart city projects. So we have lots and lots of content, if you like, and that's particularly relevant for small and mid-sized cities on how to become climate neutral, sustainable, as well as inclusive. So we sit on a lot of information and experience and knowledge, actually. Next slide, please. So we're not doing that alone. So we're embedded in a larger, so let's call it an ecosystem, if you like. So right in the middle, you see the logo of the Smart Cities Marketplace. But we do work together with, for instance, the Covenant of Mayors on climate and energy. We work together with Net Zero Cities, with our sister project, Scalable Cities. We also have links to the Covenant of Companies for Climate and Energy, who are focusing on delivering climate neutrality to small and medium-sized enterprises. And basically, we have sort of three-prong approach with that. So we have, we work in the area of buildings and energy. We work in, that's the sort of the red bubble that you see there. We work with projects related to urban mobility. That's the green bubble there. And we have an IT arm, if you like, an information technology or digital arm. So looking at urban data platform, sensor IoT, and that sort of thing as well. So three types of, well, let's call it themes, if you like, in the Smart Cities Marketplace. And given those themes, we also have links with yet other facilities and initiatives under the European umbrella. And as I won't dwell on all of the logos and things, but that's quite clearly explained on our web platform. So we're not doing this alone. That's the message of this slide. Thank you. Next slide, please. I'm saying we're not doing it alone because one of the core things that we do is try to match smart city project proposals with an investor network. And this is a private investor network. So these are funds and private investors basically looking for smart city projects exactly in those three themes: mobility, ICT, as well as the built environment, the infrastructural project, you could call it as well. So we have a number, and it's a growing number of investors, each with their own risk appetite, with ticket sizes, and the amounts that they are willing to invest, and also the specialities as well. For instance, you see we have investors that are really interested in energy efficiency projects, whereas others are more interested in for instance, heating and cooling networks as well. So it's a blend of approaches and priorities there, and I think that's also needed given the breadth and depth of the thematic focus of the Smart Cities Marketplace. Next slide, please. Now, if you would be interested in applying for services, and I should say all of these services are free of charge, actually. You can sort of come to us as a city or a city consortia, and we'd love to see you coming in from small and mid-sized cities, although I have to say larger cities are also welcome, from countries that also participate in or are sort of eligible to participate in the Horizon Europe program. So you can come to us with your proposal, and what we would try to do is to match that proposal, if you're looking for finance, with our private investor network. But also, if you are a business, either an SME or a larger business, or you're a project developer, we're also encouraging you to contact your relevant city administrations to see if you can form a consortium and then come to us as a consortium. And obviously, if you're an investor and you'd like to join our investor network, if you're looking for interesting projects in European cities, so we're open to that definitely as well. Now, next slide, please. So what do we do typically? So we do run what we are calling matchmaking events, basically like brokerage events, where project developers or project proponents can sort of meet with investors to sort of understand where if there's scope for a deal meeting, and that's actually the last serve, where you can actually sort of shake hands and say, okay, this is a really interesting project. The investor is really willing to invest in this project. We have capacity building interventions like financing masterclasses. We run webinars like this one. But we also provide so-called technical assistance, like one-to-one consultancy services, where experts from across the consortium and beyond help cities with concrete problems to advance, the maturity of their project proposals. And then we have peer-to-peer exchanges in let's say, community groups as well with like-minded people. Next slide, please. Now, if you would be interested to submit a project proposal to us, there's a very simple application form available on the site, and there's a link actually in this presentation, and this presentation will be shared post the meeting, so you can then click on it and find it quite easily. Next slide, please. And we have lots of guidance on actually how to fill in that form so that we get a sort of mature proposal from you. So lots of guidance materials that are available to you. Next slide, please. And we also have a help desk. So in case you have, additional questions, if you sort of, find that there is, things missing from the guidance material, you can just come to us via the help desk and we'll respond to your query. Next slide, please. And then in the broader sense, all the materials that I just was mentioning is available on the website, but there's definitely more. So on the website, we sit on the so-called project database, and there's now over, I think it's 87 now at the moment, 87, 88 projects, project profiles of projects, happening or closed even in all across Europe, across these themes, mobility, energy, as well as ICT as well. So you can read those profiles, you can look at the lessons learned, you can look at key deliverables, but you can also look at sort of, the key performance data. So what was actually achieved with those projects on a number of KPIs as well. And those KPIs, we have that information because we also sit on something that's called the self-reporting tool, where we ask projects to submit, quantitative data on project performance. That allows us to aggregate these data and also to provide some benchmarking information to you, so you can sort of see, okay, what type of technology delivers what type of result in what type of context. That's basically what we're trying to do here. So that combination of the project database and a self-reporting tool is actually a very good resource for those of you who are looking to sort of replicate and learn from experience across Europe. Thank you. Next slide. And then we also have a range of papers and booklets, so-called solution booklets and policy papers across a number of themes, clearly also related to mobility, as you can see on e-buses, for instance, as an example. And this is a growing set of like little guides, easy to read, non-academical, hands-on information that can help you sort of develop your own projects across these technology spaces. Next slide, please. And then we have an interesting developing going on. Actually, I'm sort of responsible for this, and we are actually creating a so-called wiki within the website, and that wiki follows the so-called climate neutral and smart city guidance package. So what we have done is, that's actually a document, for those of you who don't know, it's around 200-page document. And we have sort of morphed that or transposed that document into a whole series of wiki pages, and then linked all of those wiki pages with indeed project information, the solution booklets, the key performance information, but also events and things like that. So it becomes like a richer resource and also a more maintainable resource. Actually, yesterday we did the beta release, and we're hoping to do the release 1.0 in the Smart Cities World Expo in Barcelona in 2 weeks' time. So if you're interested, keep following the news here. So that new wiki will be sort of a key sort of new core of the website, and we will keep developing that over the next years as well. Next slide, please. And then we have all kinds of other resources for you, stories and lessons learned. We have videos and we have podcasts as well. So we have like a multimedia approach to transferring the knowledge that we capture through our interventions. Next slide, please. Then coming back to that portfolio of, let's say, matchmaking requests, if you like. So up to date, we have received 127 proposals, bankable project proposals, representing a value of over 600 million euros. This is quite considerable. But we're looking to receive more. So interested to receive your proposals, so that we can try to match that with our investor network. Next slide, please. Yeah, then with that little introduction of the Smart Cities Marketplace, I want to hand over to Malte and Jochem, who will then do a little deep dive into, okay, hydrogen. Is that now a really interesting development for our city energy system? And will it help us to deliver on our climate neutrality missions in cities? So I want to hand over here to Malte and Jochem now, and then I'll come back towards the end of the webinar. Thank you very much.
Yes, thank you very much, Eelco, for the nice introduction. My name is Malte Rens. I'm working as a consultant at DNV on the theme of hydrogen. I'm joined today also by my colleague, Jochem, who's a senior consultant, the same team basically as our colleague Ilko, joining in from Groningen, the Netherlands. And during this session, we will provide you with a bit of an insight on general developments about hydrogen. What is hydrogen actually? Physical properties, but also its application in various sectors of built environment, transport, as well as industry. So very much looking forward to this presentation. All right, I'll give it a go. With starting actually about talking about hydrogen and why at all we should talk about hydrogen. Well, I think we all agree that we need to get to a more greener future. Right now, our energy systems is still dominated by the use of fossil sources, and towards the achievement of our Paris Agreement goals of 1.5 of staying below 1.5 degree warming of our climate, we need to become more green. And also, we actually really need to start with it. I mean, you may even say we really need to accelerate. What we see here on this slide is, I think, pretty much familiar to probably most of you. The story that we hear from our IPCC, climate reports, which really indicate, on the one hand, on the left side, where we're going to end up if we stay with the current implemented policies. That would mean a climate warming of up to 3.5 degrees Celsius, and where we need to be, what kind of emission reduction pathways we would need to follow if we want to achieve our limiting the warming to 2 degrees or 1.5 degrees. And you can see there's a wide gap, so a critical call to action actually. On the right hand side, we see also that the different sectors basically that currently emit greenhouse gas emissions. And pink, the transport sector, blue, the energy supply, as well as our land use, such as forestry. And we notice that across all of those sectors, we need to cut emissions. But how do we do that? Well, we're going to look at now at the final energy demand and the projected energy demand over the next decades. And here you see the current system, basically, where the bit blurry lines start, still dominated, of course, by a lot of fossil energy sources from the bottom to the top. Coal, oil, dominating natural gas, as well as future more use of bioenergy, hydrogen, ammonia, as well as e-fuels. And the main message here is basically that we see that electricity, of course, will play a large role, basically double in its share of our final energy demand mix, and that's a good message, because that electricity will largely come then also from sustainable energy. Hydrogen, when we talk about hydrogen as an energy carrier, is basically, if you look at the overall picture, rather negligible today. We see it starting really for the 2030s. And by 2050, though, hydrogen represents almost up to 5 or 6% of global energy demand. So we'll see a significant increase. To summarize that part, basically, we see that the pathway to net zero, to a greener future, is technically and politically feasible, but really requires a strong policy implementation to reach 1.5 degrees Celsius. We have to reduce our emissions across the different sectors significantly, And how to do that? Renewable electricity will play a very big role. Hydrogen and bioenergy are also essential, but will need to be complemented by zero emission and negative emission technologies such as CCS and direct air capture and land use change. Yes, and last but not least, we need to speed up as soon as possible. Time is really a critical constraint here. Now I'm going to start with diving into the physical properties, basically, of hydrogen. I'm going to look at that. But to start, I would like to invite you actually to scan the QR code on this screen here and answer the first question that we pose, just to get a bit of a background on your current knowledge level, let's say. So please use maybe your smartphone, scan the QR code, and indicate your level of knowledge. You see, we have already some responses coming in. Some experts that probably are already at a higher level than me and my colleague with a level of 5. Let's give it just a couple of more seconds for you to respond. Beautiful. So I think we can see from this basically an average score of 3.0. That's actually quite nice, so that I don't have to really go into the very details of hydrogen as its physical properties. So we can probably already start with a bit of more detail. Thank you for your inputs here. So what is hydrogen? Then just very briefly, at room temperature, basically, it's a very light gas. It has, in terms of physical properties, second lowest boiling point and melting point of all substances, just second to helium, which means very, very, very low temperatures, just basically 20 degrees above absolute minimum temperature. It will be liquid. It has a rather small volumetric density compared to, take here, natural gas, with a factor of 9, basically. However, a rather high mass density. So if we consider the kilograms of hydrogen, that is a factor of 3 to 4 higher than natural gas. We look at how hydrogen moves in air. That's basically the diffusion, that's what it's called. It moves more than 3 times as fast as methane. However, also to mention here, that we'll look into that later on as well, hydrogen can also diffuse into solid materials, such as metals, this mechanism. So this effect of high diffusion can lead to hydrogen abridgment, so basically wear and tear of material. Therefore, the materials to be used in contact with hydrogen really need to be carefully selected. When we look at when hydrogen is flammable, the flammability range basically gives the range of gas concentrations where gas might ignite. So for hydrogen, this is a range of 4% to 75%. And this basically means that there's a very high range. So this needs to be considered to design safe systems. Some other aspects of hydrogen are its detectability. Other than natural gas, it's really odorless, so you can't smell it. You also can't taste it. You can't see it. So you really need good sensors to detect hydrogen, particularly in enclosed areas. And a good point here is as well that there are certain odorants, certain products that you can add to hydrogen, so that you can actually smell it. For example, if there's a leakage, that you can still smell hydrogen leaking. It's not non-toxic and neither poisonous. It doesn't create any fumes. And in terms of asphyxiation, so also not more concerned than other gases. So just in a nutshell for this first part, why do we look at the development of hydrogen at all? Well, decarbonisation is the current driver for hydrogen developments. Next to electrification, hydrogen will play a big role in our energy system. Hydrogen has indeed already a role in there, but is indeed next to is not the single answer. And hydrogen has different physical properties compared to, for example, to natural gas, which influence its application. I will get to that in a bit. I'd like to present to you now is the hydrogen value chain, basically. So how does it actually look like? For those who are familiar with the value chains, it's maybe nothing really new, but I'll just go briefly about what an energy value chain actually is. So from the left to the right-hand side, basically starts from energy sources. So exploration could be coal, gas, but also biomass and wind, solar. Moving towards the right-hand side from its production. Let's take, for example, biomass, the digester, its transport, either via pipelines or ship, for example. Being stored, for example, underground storage, further distributed via municipal networks, and eventually converted and used, for example, in a CHP, combined heated power plant in the municipal environment. And if you look at hydrogen particularly, we just present here one of the many, let's say, hydrogen value chains. We can see that, start from the top here, from the top left, one potential hydrogen value chain starts at wind. If we want to look at sustainable hydrogen production, electricity generation by wind turbines, transport via electrical lines towards an application called an electrolyzer, for example, a powered gas plant, which produces hydrogen, center basically here. Then it's transported, distributed, and again also converted and applied in different end uses. The alternative, let's say the more conventional way, that's let's say the third row, the exploration of natural gas, where natural gas is used to produce hydrogen. The process called steam methane reforming, predominantly, and then transported, distributed, and converted towards its end use. Right. Then I'd like to move on towards hydrogen applications in the built environment, in industry and mobility. But again, before doing that, I'd like to invite you to ask a very simple question again via this link. And the next question will come up now. This question whether you, because we are really interested, whether you are currently already exploring or implementing hydrogen-based solutions in your regional energy system, or whether this is something completely new to you. One response at the moment. Give it a couple of seconds. Right, there's probably some. So again, please feel free to use the QR code here and indicate whether you already experience the implementation of hydrogen-based solutions in your municipal system, for example. Right. Okay, let's move on, I think, from this. So it looks like responses received that it's really a rather new item in the context of the built environment, for example, municipalities, etc., at least for the current audience. So what I would like to go into more detail now is in the end use part and the distribution part of hydrogen, a couple of more concrete examples of it as well. And then we're talking basically about target market segments for the implementation of hydrogen. And those are the so-called hard-to-abate sectors, and sectors where basically other decarbonization options are not a real option other than hydrogen. And then we're talking about aviation, maritime, heavy industry, which require often other alternatives to like in comparison to electrification. So, let's move on to the right-hand side of this picture. We see where hydrogen applications make sense, and on the top left is where it's possible to apply, but it's not really competitive given the alternatives. Look at low temperature heating, competing basically significantly with heat pumps, but also on the end of towards well, it's basically a bit of a break-even point with heavy-duty transport. Again, it's a good ability to implement, but it also has competition from battery electric trucks, where it clearly doesn't have a real added value is again in the mobility sector for passenger vehicles. So we all see a high dominance of battery electric vehicles. But looking more into also the current applications of hydrogen and where it really makes sense, called premium customers on the top right, we see hydrogen being applied in industry, refinery processes, the production of fertilizers via the production of ammonia, but also high-value chemicals such as methanol. In future, we look. That's probably also very interesting for your city's environment. We see applications in the medium and high temperature heat environment, as well as iron and steel. We can go into more detail about that in a second, as well as mobility and shipping and aviation. It shows higher demand potential. Talking about industry demand currently, basically you see a high non-energetic use of hydrogen globally. And touched upon that briefly in the previous slide. Ammonia for fertilizer production relies heavily on hydrogen. Also refining processes, basically of, for example, of crude oils, as well as production of high-value chemicals such as methanol. Those are the biggest current consumers of hydrogen, basically. But also those sectors need to decarbonize. So the need of green hydrogen is high here. One of the more upcoming sectors, and that is again in industry, would be steel production. what we see basically the current processes, and that's shown on the right-hand side. The figure, the left pathway, let's say, the production from iron ore towards crude steel, like a high value product, is heavily, well, depending on coke, basically carbon. And throughout this process, a lot of CO2 is emitted. Good message here is also that with the substitution of coke by hydrogen, we can avoid a lot of emissions throughout the steel making process. And we actually see these applications being tested, demonstrated currently, for example, in the Rahe steel plant in Finland. More applications in industry are like industrial burners. We actually had I actually had experience previously with the cheese factory that wanted to substitute natural gas used for steam generation, basically in a big burner where natural gas is burned to generate heat. They were looking into alternatives such as hydrogen. So that could be an interesting application as well. Looking into engines not driven by diesel or oil, but by hydrogen or hydrogen derivatives such as ammonia and methanol. But also in the built environment, domestic appliances, like the smaller scale burners, let's say, for your residential heating demand. In mobility, also hydrogen is nothing really new, but is currently also being rolled out, as mentioned before, mostly in heavy duty transport. You see here refueling of a truck in the Netherlands on the left-hand side, as well as other established demonstrations, for example, in Iceland for bus transport. But there's also a possibility, as you can see below, in aviation, where planes can be driven by fuel cells running on hydrogen, as well maritime, big ships running on hydrogen or hydrogen derivative, energy carriers, as well as rail transport. So to summarize again, this section on the end users can basically say that the majority of hydrogen is currently used as a feedstock in the chemical industry. The demand for green hydrogen to decarbonize those sectors where hydrogen is currently used is going to be high, and it's going to be in ammonia methanol refinery. New markets, for example, the steel manufacturing industry. And in terms of mobility, we really see that fuel cell electric vehicles are mainly envisioned indeed for heavy duty transport, as well as shipping and aviation sector. I think now we're going to move on to actual lessons learned from hydrogen projects we saw and could observe at DNV. We're going to start off with the distribution part of the energy value chain, transport pipelines for hydrogen. And again, here we can see dedicated hydrogen grids actually being already existing. In Belgium and France, Air Liquide has an existing network of more than 1,000 kilometers. Same in the Netherlands, we have products operating a pipeline in Rotterdam of roughly 140 kilometers. And beyond, there's more applications of dedicated hydrogen pipelines. It's good news, it's something that's already existing, but predominantly locally centralized. But what if we look into the future, look we saw also a decrease in the coming decades of natural gas demand due to decarbonisation efforts. What if you can actually reuse existing natural gas infrastructure for the transport of hydrogen? What you see here is actual concrete plans by Gasunie, the transmission system operator for gas in the Netherlands, to roll out so-called hydrogen backbone transport system for hydrogen in the Netherlands. And that involves really, as you can see, the yellow lines, the existing pipelines, whereas the blue lines would be new dedicated pipelines. So a large extent really would rely on the repurposed existing natural gas pipelines. Or even if you want to go bigger, why not looking at a European hydrogen backbone, being able to transport hydrogen across Europe via a dedicated system. Well, but before doing that, because this is something rather new, the repurposing reuse of existing natural gas pipelines, would have to check a couple of things. I mean, we look into now pipeline material, but so what would be the impact of use of a different energy carrier than natural gas on the pipeline material? What are the risks associated to it? And also on the end user side, what would happen if you have hydrogen rather than natural gas? And what we see throughout the different projects running as well is, we touched upon that also briefly in the beginning, in terms of material behavior, that hydrogen really can impact steel, for example. It could increase the wear and the tear of the material, so-called hydrogen embrittlement. In terms of pipeline risks, we talk about risks, basically that's composed of a chance, what's the chance of a risk materializing, and what would be the impact if it materializes. Again, compared to natural gas, basically what we see is that external threats are similar, whereas in terms of internal threats, like in terms of the pipeline material, there's an increased chance of fatigue, crack growth of sharp crack-like defects indeed. And in terms of consequences, well, we have no real increase in toxicity. We have a high velocity increase in terms of gas releases. We could observe flammability increases, and however, the fires with up to 25%, sorry, of by volume of hydrogen have little difference compared to natural gas. However, those findings you can only basically find if you test and do some fundamental testing. In that sense, I think it's also interesting to just show you briefly what is also being done currently at a facility in the UK, where we basically test physical properties of hydrogen. In this case here, how do deflagrations, so smaller explosions, look like with hydrogen. And what do hydrogen detonations really look like? So the message here is basically for hydrogen to be implemented, we need to also do fundamental testing. And this is currently being done. So in terms of, that's the one important point, but of course also on the end user side, and end user appliances, their hydrogen also needs to be tested. For that, demonstrate basically the findings here on the end user side. We look more into the sector of the built environment. Brought two demonstrations, two cases basically. One situated in Rozenburg, Rotterdam, the Netherlands. Another one in the UK, in Spade Adam, basically also where the previous video is originated from. So left side project in the Netherlands, we have the objective to develop and demonstrate basically technical design, guidelines, process criteria, principles. Indeed, for the hydrogen application in the form of, well, in infrastructure and pipelines, but also in the blocks, basically, as a source for, as a feedstock for hydrogen burners. You can see here the actual demonstration plant on the bottom right. 3 containers, one where the electrolyzers are located. Electrolyzers produce hydrogen. And the other one, there's a methanation unit. Methanation is also actually part of this demonstration project. Methanation is basically adding CO2 to hydrogen to produce natural gas. That could be, of course, already fed in the existing natural gas grid with little to no changes. And here the third container is basically a storage unit for the CO2. Then I'll go via pipeline, basically this way over here, across the river, and up to the building blocks on the left-hand side, where there are a couple of hydrogen boilers installed in the buildings, which provide then heat to the different apartments. Yes, indeed, I think the nation part, interesting here is what's being tested and demonstrated is the direct use of hydrogen in hydrogen-fueled boilers. We see on the right-hand side the electrolyzers, basically the closet-sized boxes with about 25 kilowatt of capacity, and 3 boilers where it's going to be fed in. All have a different purpose, basically, but all are then fed by 100% of hydrogen. The right-hand side is a hydrogen boiler, 100% commercial version already. In the middle, you can see a hydrogen boiler from the producer Decarbonisation, just to test specific components of a hydrogen boiler, in this case the burner, heat exchanger. And on the left-hand side, you can see actually a boiler that has been retrofitted by DNV. So it was previously a natural gas boiler, but has been retrofitted to burn hydrogen instead. But that is actually also possible. That's been the second phase, let's say, of this pilot project. And last but not least is also a third phase, where it has been tested to feed in hydrogen in the existing natural gas distribution grid. You see a lot of different pipes over here. And there it has been tested, basically. All those pipes have been then covered in sand, just to simulate basically realistic conditions, and then has been analyzed which basically components can be reused and how the pipelines can be cleaned. And as a matter of fact, then in terms of results, we saw just minimal adjustments were needed to reuse the existing natural gas pipeline network. Minimal adjustment, I'm saying, then talking about switch of smaller couplings, etc. And actually, I talked with my colleague about it, who is directly involved in this particular project in Rosenburg, who also offered to the audience here, if there's interest, there's always a possibility to actually visit this site, Rosenburg, in the Netherlands, if you're willing to come to the Netherlands, indeed. And the second case that I wanted to bring is a project coming forth from two initiatives, H21 and a High for Heat project. It's basically a simulation of hydrogen application in the built environment, indeed, where a whole block has been built in Spade Adam in the UK, which runs basically 100% on hydrogen. So in this case, the DNV's High Street project provides domestic end-use 100% hydrogen boilers. Those provide the heating, whereas the Northern Gas Network's H21 project demonstrates distribution of hydrogen in the below 7 bar regime of the national grid here. Certainly also something interesting to see if you're in the UK. And again, on this side, we see that many risks are comparable to natural gas. However, if we have a higher accumulation of hydrogen concentration in the building, for example, that will result in higher risks. So in terms of the findings, we see a number of leakages and outflow are comparable to natural gas. The leakage to open air is comparable with natural gas. Where it changes is the perception as a bit of the accumulation. So when it comes to concentration in the air, for example, in a room, in the building, then we see hydrogen concentrations below 10% volume will have lower risks, whereas concentrations above 10% actually result in higher risk compared to natural gas. It's nothing very critical. Actually, just need to find mitigating actions to lower that risks. A general finding, again, first to mention, to give the bigger risk picture in mind, is the probability, for example, of death from a gas explosion in domestic property is pretty similar to the probability of being struck by lightning. So overall risk is very, very low. And the risk assessment were completed in the UK for hydrogen, reviewed by the safety regulator HSE, also shows that the probability of death from a hydrogen explosion in the home is higher, but still less than the probability of being, let's say, electrocuted in the home. Introducing hydrogen into heating of houses also removes the risk of death from carbon monoxide poisoning from poorly maintained gas boilers and fires. That's on the upside. And with that, actually, I'd like to close the findings from the projects in the built environment. I'd like to hand over to Hanna Lewandowska, who's a project manager at the city of Bydgoszcz, who will, I think, present us with some very interesting findings on what keeps the city of Bydgoszcz so busy in terms of hydrogen developments. So over to you, Hanna. Thank you.
Good morning. My name is Hanna Lewandowska. I represent the city of Bydgoszcz. I work here in the city over 15 years, but since 2 years in the energy management office. And I'm the environmental specialist. In my job, I mainly deal with European projects and getting the external financing for the energy activities. The Energy Management Office in our city was established in 2016, and its main responsibilities is purchase of heat, electricity, and gas, not only for our city, but for the Bydgoszcz procurement group that is made of the municipalities of metropolitan area, of the functional urban area of Bydgoszcz. And also our office analyzes the energy demand for municipal buildings. We plan the energy budget for the municipal buildings and manage the heating system. We're responsible for the heating switching off and on, and the agenda of the heating in schools and in other buildings. Of course, our responsibility is increasing of renewable energy, and we manage and run energy database. We are responsible for the invoices, electronic system. We have the electronic system that reads the invoices and forward it to the different city entities. At the same time, it collects all data about the energy consumption and the contract parameters of energy. We participate in international projects. We try to learn from others, exchange experience, and be involved in networks. We are a part of Covenant of Mayor. Recently, we adopted a CCAP, and the new CCAP that is valid for 2030. And we organize for our city events and conferences that tackle the energy issue. I'm sorry, I think I missed a few information about our city. I had the slides on the beginning. So maybe shortly, just to give you a picture that our city of Bydgoszcz is sorry. Our city is quite a big city. It has 330,000 of inhabitants. The most part is dedicated of the economy is dedicated to industry, and we have in our city the production of hydrogen buses. Recently, they came to our city, and the railway railway company that also is producing the hydrogen trains, or planning to. I'm not sure, but they have this in their offer. Polish hydrogen strategy is very ambitious, and it assumes that until 2025, Poland will have a minimum of 100 hydrogen buses and its fleet, and until 2030 it will be increased tenfold. It also assumes that we will have 32 hydrogen fueling stations, and it sets some indicators and main actions that are visible on the screen. I won't read it for you, but it has a very ambitious actions, aims, and indicates what are the indicators for this strategy. As a city, we don't have the hydrogen installation yet. We have few photovoltaic farms in our city, but they don't belong to the city. They belong to private investors, and we have a lot of land that is abandoned or brownfield land that cannot be used for any other purpose, or has to be remediated or recultivated, and requires big investments. But we think that it can be used. These areas might be used for producing the energy and for building the photovoltaic farms. Therefore, we made inventory of this land. We found 10 possible locations for the photovoltaic farms, and we use the European City Facility offer that 60,000 euro grant to get a concept for this photovoltaic farms. When preparing the concept, we also wanted to include on one photovoltaic farm the demonstration installation of hydrogen that will fuel just several public transport buses, hydrogen buses. And so we applied to European City Facilities. We received the grant. The European City Facility is the grant that cannot be used for the investment. It's 60,000 euros, so it's not possible even to finance investment, but it allows to prepare some investment concept, make some financial analysis, feasibility studies, market analysis, and whatever is needed to develop the investment concept. So, as I mentioned, our application to EUCF involved to build 10 photovoltaic farms with a demonstration hydrogen and station, and the land is owned by the city and by city itself and the city companies. We defined 4 phases to prepare technical design project and obtaining necessary permits. We checked within the concept what kind of permits would be needed. We defined that we have the company incineration plant that has the permit for energy selling. So we defined which company, which entity could be responsible for this project and run the project. We made some financial analysis to show how much money is needed, how much money we should gain from external funds, and define that 16 buses might be fueled from the photovoltaics that we designed on this area. The total investment we estimated as 52 million euro. Most of this costs belongs to the hydrogen installation and buses. We calculated that in this way we avoid 21,000 tons CO2 and generate 31 gigawatts energy per year. We will have one hydrogen installation and fuel station and 16 hydrogen buses. This is only, we are at the first stage, initial stage, preparatory stage. We have dream. We don't have exact plans. We have concept. We define stakeholders and possible financial sources. But at the same time, we are exchanging experience with other cities. We participate in projects, horizon projects like My Smart Life, that we were a follower city. So we saw some of the installation in Hamburg. We try to get to possible support of experts. That's why we applied to Smart City Marketplace for technical support. This is the time, yes, that I would say thank you for this possibility, and we try to get as much knowledge as it's possible, and hopefully we will start investment. We have also in National Renovation Plan the possible finances for hydrogen. The National Renovation Plan is not yet available for Poland, unfortunately, due to political decisions, but hopefully it will, and it will involve also the hydrogen investments. We have in the city, we have the incineration plant that produce the energy of 60 gigawatts per year. And recently we managed to sign the contract using public procurement regular procedure to illuminate the city. It's unfortunately it's not possible to make it as in-house. So we had to. So this incineration plant, that is the public company, the city company, has to take part in public tender, but offer the best price. And this is our first step for being self-sufficient. We hope this photovoltaic farms in the future with hydrogen green hydrogen fueling buses will be the next step to achieve self-sufficiency. And also biogas plant that we already have, but also few biogas station that we plan to build. At the end, we might be able, we will have enough energy to provide the energy for the whole city, not maybe for the citizens, but maybe in the future. We are a big city, so it's a big challenge, but we also hoping for a new law that allows this self-sufficiency to provide the energy, to use the energy that we produce, because at the moment it's not possible. That's just a short story about our the start of the way to the hydrogen production. Thank you for your attention, and if you have any question, you may ask, of course.
Thank you. Thanks, Hannah. That was really helpful, and it's good to see case studies of hydrogen implementation. I'm gonna go through the details of like the fact that it's actually not that easy to deploy, also from a financing standpoint. So that's really an accomplishment. Is there any any question in the background? All right. If not, then I'll thank Hannah, and we can potentially bring you back on stage eventually, if some of our guests will want to ask a question directly. All
Obviously.
right. Thank
Thank you.
you. Thank you so much. All right. So good morning, everybody. My name is Tommaso. I'm a senior analyst at Bankers Without Boundaries. We're a social enterprise powered by former investment bankers who work at the intersection of city-related projects, sovereign kind of activities, as well as mostly multilateral development banks, DFIs, and we provide technical assistance. We offer financial modeling for cities and all the support that can be offered in terms of sustainable finance at public and some private actors too. We are the main financial of the Smart Cities Marketplace, and today I would like to complement some of the content that has been shared with you so far on hydrogen projects, and specifically to focus on financial strategies for project development. Uh, we will go through quite briefly the general financing and funding landscape in the European Union. We'll then focus shortly on the EU public funding landscape, with some additional attention being paid on IPCEIs. I'll tell you in a second what that means. We'll move on to then private finance for hydrogen projects, challenges and opportunities, and conclude with potential collaboration between these two sectors, so with public-private partnerships as well as blended finance solutions. So this is the agenda for the day. As for the others, you're utmost welcome to share your questions live. There's a chat for you. Sabine will be kind enough to let me know if there's any specific questions that you have. So let's start today from this overview of the hydrogen financing and funding landscape in the EU. As a reminder, since not all of us are, let's say, fluent in the finance language, and also because it tends to be used interchangeably, I would say, with quite some frequency. Financing, when we talk about it, we refer to the capital that's provided by mostly private institutions, private investors. We're thinking here about capital that has to be repaid. Okay, so whether it's for a project, whether it's for an enterprise, we're talking about repaid capital. Whereas funding, generally, whether it's provided by the government, by the EU, or by any other entity, it's non-repayable. There are some additional nuances to it, but I would say that this is the main element. All right, so let's dive right in. This taken from a very rich study done by Kneebone in 2023 is quite a strong, quite an effective overview of what's going on in terms of financing and funding of hydrogen at the European Union level. We see that it starts from EU ETS, so exchange traded system revenues. You know that the EU has an allowance scheme that allows corporations to use a maximum of CO2 allowances, and then to trade to emit more, or to exchange to if they emitted less, and that the revenues from there are channeled among other projects also into hydrogen projects. We talk about bonds, so capital collected on public markets. We talk about the EU budget and member states. We see that is channeled into different kinds of sub-funds, whether it's the innovation fund, whether it's life programs, whether it's InvestEU. And we see that the most relevant and most capitalized among all of these, we could say, that also revert to hydrogen projects, are the InvestEU program with 300 billion, Horizon Europe, Next Generation EU, Of course, not all of this capital is for hydrogen, but let's see at the second stage. The second stage, we have the effective projects and the effective funds that directly invest into hydrogen, whether it's the hydrogen bank that has an allocation of 3 billion. We have also funds such as the Clean Hydrogen Partnerships, the Recovery and Resilience Fund, and the one that we're going to talk about in a second, the IPCIs. And the most recent ones are the High Y2 Tech and High Y2 Use, and I'll tell you in a second what they are. But this is a really effective overview of the general landscape for funding. When we talk about the member state specific, there are some allocations that are done precisely having hydrogen in mind, in particular from Spain, France, and Germany. France is allocating roughly 2 billion on hydrogen funds. Spain, more like 9 billion, and Germany, depending on how we calculate that, but it can vary between a few billion all the way up to 15 to 20 billion on hydrogen. So that's definitely quite significant allocation, I would say. Next in line in this landscape review is the blended financing instruments. So here we're talking about contributions of member states linked to the EU budget MFF, so the multi-annual financing framework, and how it links to private investment. The member states and EU budget allocation, as you can see, they represent the largest part and the largest option. We already also have a clear idea of the allocation that these provide, but private investments contribute, for instance, through the Breakthrough Energy Catalyst program, the Net Zero Europe platform, and all of these are also supported by the EIB. The EIB, as you know, provides not only direct investments or lending, but also provides technical assistance. It provides guarantees to de-risk the investments. So the contribution of the EIB to all of this doesn't necessarily have to be exclusively capital deployment related, but it can also be in the form of technical assistance or guarantees. Now, let's move on to the next step, which is to focus on the EU public funding landscape. Okay, so going a bit more in detail in this sense. And starting from this, we have a zoom on the hydrogen important projects of common European interest. So I've mentioned them a couple of times already. These are the IPCEIs, and you might already be familiar with them, but we consider them to be collaboration in the public and private sector. So where private initiatives supporting breakthrough innovation infrastructure fail to materialize because of the significant risks that projects entail, the EU state aid rules enable EU countries to jointly fill in the gaps to overcome those market failures with IPCIs. And so what are they? They are ambitious cross-border projects important to the contribution to the EU initiatives, the limit potential competition and distortions. All right, so these are projects where the member states provide direct aid, and they don't qualify for the general strict rules that the EU has for against state aid as unfair competition. In some scenarios, whether it's for battery technologies, whether it's for hydrogen, the EU does offer this opportunity, and it's a way in which the EU does indeed support. These are cross-border initiatives, and that's specifically what allows them to be, let's say, taken out of the general considerations about state aid. And on top of that, I shall also mention that EU countries can lend support to hydrogen projects also through a whole set of other initiatives, whether it's the general block exemption regulations or others. These are really other ways in which the EU does support. These two EPCIs, the two main ones, they start with the one approved in July 2022, where the EU Commission has approved the IPCI HY2 tech. And this way, member states provide up to 5.4 billion in public funding, which then unlocks up to 8.8 billion in private investments. All right. This, as you can see in this picture, has and shows the participation of a set of different EU member states. Here we're mentioning up to 15, and it's not just hydrogen, it's fuel cells, and user technology. It's not just hydrogen generation, I want to say, but it's also fuel cell technology, storage, transportation, and distribution, and user technology. So it's really trying to unlock with this 5.4 billion, with the additional potential 8.8 billion that can be unlocked with private contributions, the whole value chain of hydrogen. And this is really what makes it particularly useful. And you see, by each country, you'll see the main companies that are in charge of this. So in Italy, you have Enel, De Nora. In France, you have Elogen, Genvia. In Belgium, Communis, etc., etc. So this is really this participation and this joint collaboration, let's say, at all levels, that allows this to happen. The other IPCEI is HY2 use. This one followed the HY2 tech, and on top of what was done previously, this focuses more on hydrogen infrastructure and hydrogen applications in the industry. So what's really important here is that you're creating an environment, and this is the one I'm talking about, the HY2 use. You're creating an environment where there's really cross member states collaboration, and there's really an effort to unlock not just public member states support, but also trying to bring in the private sector as well. And this is what the strategy of the Commission looks like in this sense. Now, if we want to think just about private lenders or private sector considerations when going about financing hydrogen projects, so asking for repayable capital, well, there's where some challenges arise. And this is why I would like once again to stress how significant the work that has been done so far by Hannah, but also by the city of Bydgoszcz at large, because of the difficulties that in general these kind of projects do encounter, and we'll go through them really in a second. So let's start with a few considerations, right? While there is merchant market for, of course, electricity, for a lot of energy production and energy vehicles, that we can say, tools or whatever in general, there is really not a merchant market for hydrogen, right? And to be financeable, hydrogen project must have a bankable offtake scheme, right? When thinking about which ones these should be, well, a few come to mind. The first one is ammonia. Ammonia has already quite a functioning market that exists. Ammonia, of course, we say this because it can be derived by hydrogen. This was mentioned also previously, right? It's one of the byproducts that can be produced through hydrogen, or which we can use to make hydrogen, right? And several green ammonia projects are in large stage of development, and it's easier to transport. It can use also for fertilization and all of other things. So there's really something which hydrogen can directly chip in. The second thing is refineries, so petroleum and oil refining. Refineries are among the largest users of hydrogen as fuel stock. As an early stage, hydrogen projects might make contract with refineries and off-takers, and several pilot projects also be developed in this sector. This doesn't necessarily fit into a general overall decarbonization strategy, but it fits into a strategy whereby we make hydrogen viable and hydrogen projects viable. So this is something that's sort of like a borderline kind of a off-take activity here, because we don't want to invalidate the role of hydrogen use by um, by exactly pushing forward projects that are not so environmentally friendly, we can say. And the third area is fuel for specialty vehicles. So right now we have already hydrogen for power fuel cells, and they can be used especially for long haul transportation of vehicles. So really, this thinking is to start thinking in ways where there's already a market, or a market can be more easily tapped into when we're talking about hydrogen funding financing. So this is what we're saying. And in particular, if we want to look at some of the most promising use cases, and we see also why the city of Bydgoszcz is going into that direction, public transportation is one of the first one that comes to mind. And why is that? Well, fuel cells have advantages over batteries because they're quite good at powering heavy transport. Hydrogen refueling is much quicker than recharging batteries. So also, if you're thinking about operating a fleet, if you're thinking about having constant usage of a fleet of buses or even trucks, thinking about that, we need also to think about a refueling time. Thinking about the materials that need to be used to have very large batteries that can power this kind of public transportation or long haul transport kind of vehicles, it can be more complicated, it can be more challenging if we wanted to do that with electric batteries. And instead, amount of hydrogen fits this better. We'll see how that happens. If also the prices can be competitive, if there's a large adoption of it, like a lot of these considerations, and we'll go through in a bit later, depend on system considerations and on or sort of like having an ecosystem that works. Hydrogen for long haul trucking is more difficult to model to finance because we rely on more dispersed refueling network, and that's the main reason, right? The second one is the energy storage to supplement intermittent power generation. So in areas with high renewables penetration, we might already have batteries for energy storage, not to waste all the precious electricity and energy that is being produced by whether photovoltaic or by wind turbines. But sometimes storage batteries cannot be as efficient in storing for the longer term, or we would need very large ones to store large amounts of energy. And that's why having hydrogen energy storage can really be useful to hedge the risks of an intermittent power generation that is brought about by electricity, by renewable electricity programs and projects. And there's several underway in the US, and they can also, hydrogen can be generally used for longer term storage without as many problems as a battery would produce. And lastly, very financially viable use case is the one of using hydrogen for industrial processes. So whether it's using for cement, for high temperature kind of projects, then these are use of hydrogen is really potentially effective, because in some region you can deploy multi-project facilities and combine them with renewable generations, and then reuse that hydrogen for in the location energy production for high temperatures and similar. So we should not forget also there's a set of financing challenges to it, and some of them financiers are considered by financiers from, let's say, a more risk standpoint, whereas on some other cases, there's a project coordination set of hurdles. So starting from the main risks for financiers, well, the corporate counterparty risk is one of the bigger ones, because in general, what financiers love and repayable capital providers love is a long-term fixed priced project that provides constant revenues in a stable fashion, and that allows to forecast the repayment periods quite easily. And this happens, and we sort of like achieved a way to calculate that quite easily with renewable generation, with purchase agreement contracts and similar. It's quite easy now to model what the overtime payback period of wind turbine projects or solar can be. With hydrogen, it's not quite the case, and having to operate with corporate counterparties that are mostly putting forward this kind of projects right now can be potentially problematic, and sort of like doesn't give the same stability as it does for electricity and for renewable energy kind of produced production. There's a small balance sheets of hydrogen suppliers and producers, so this is something that should not be ignored, because the overall default risk of a project is related also to the balance sheet of the hydrogen project leads. Technology risk, so not just the fact that the technology might not be as effective as promised, but also the adoption element. Can we bet on a technology that's right now not being used that much, that is still quite marginal, especially in the use of private vehicles, right? Is hydrogen going to be more relevant in the use of public transportation or private vehicles? We don't know yet. There are some advantages and disadvantages, and there's sort of like the adoption risk that shouldn't be ignored. And this also represents and explains why the overall hydrogen risk is and demand is much less clear to forecast than the one for renewable energy. Right. Moving on to the project coordination hurdles. Well, as I said previously, to have a functioning hydrogen system and infrastructure, you need to have all the steps working. The same we can think about the same thing that happened for oil in the past and for car usage, right? Until when we had streets, we had oil pumps, we had repairmen all over the country and all over the areas. It wasn't really easy for people to use cars and start adopting them. Same for hydrogen specific power technology. If we consider that some of the elements of the supply chain and overall chain in general might not work, then we understand why there might be project coordination hurdles. Also, finding finance for the project needs an ecosystem approach. We need to raise the finance end to end, and SPV might be the best tool to do that. So, can I ask? Can I ask to the organizers if you can still hear me, because I see that the screen looks stuck. Maybe it's just on my end, so if you can still hear me.
Tommaso, we can still hear you, so please continue. But it might be that you have a loss of connection, so I would then rather bring Elko to stage. Could you take over?
Thank you, Sabine, and thank you, Tommaso, as well for. I think the best. I think you went through the best part of your presentation in terms of number of slides. So maybe we can already start to move into a short discussion on what was presented so far. Maybe I want to bring back, hark back to my colleagues, Rens and Jochem, because we are sort of, almost sort of, in two minds here, because we've seen a case for hydrogen buses here, both from the city of Bydgoszcz, and we heard Tommaso say that there are certain particular interesting use case for hydrogen buses. However, in your slides, you had this little, these quadrants, and I remember from, let's say, heavy duty transport being sort of sitting on the fence, if you like, being undecided. So it could go either way, basically. But what, from DNV colleagues, what would be considerations to go for electric buses rather than hydrogen buses? I mean, we heard Tommaso say that, there are some use cases really relevant for hydrogen buses, but we do see electrical buses running around in the city context all the time, right? So even in the airport, you see them in certain cities. So maybe you could sort of give the audience some pointers, or what are deciding criteria to go either for hydrogen buses or electrical buses.
And I would say we would take that question to Marta, and afterwards we have Tommaso back. So you could finish your presentation very shortly, and then we would bring all of you again back to stage. So I would give the floor to Marta quickly, and then back over to Tommaso.
Yes, let me give a try to answer that question, and I think Jochem, you can also probably add to that, because it's actually quite interesting indeed. The hydrogen fuel cell based buses that we actually also see around in the city of Groningen here in the Netherlands, at the same time as you see fully electrified buses. And I think indeed the advantages are, as Tommaso explained, the high speed of recharging of hydrogen-based buses. But overall, what we also see is that basically a lot of investment also goes into fully electrified buses. They're picking up quite some pace, especially if we look around the city core. Probably that's what my personal opinion is then. When you particularly look into those lines that go towards the next town or the next village, which are typically a bit of higher distances, that would be more to the advantage of hydrogen-based buses compared to fully electrified buses. But yeah, as you said, it's a bit of sitting on the fence. Jochem?
Yeah, an additional aspect to that is also the availability of infrastructure for charging or for fueling up a bus. There are cities that have, for example, have an old and protected inner city. It's a question of whether buses can drive there or not, but and there is a question if electrical infrastructure for charging the bus can be placed, can be feasibly built inside a city, and it has a much bigger impact than, for example, building a hydrogen charging infrastructure. So it is, let's say, it has to be evaluated case by case, which one is the most suitable. But there's different aspects to it that we now just mentioned.
Thanks, colleagues. So Tommaso, we have you back, I think. So I understand you have 3 more slides to share from your presentation. So do go ahead with those, and then we come back to the discussion.
That's it. Thank you so much. Yeah, probably StreamYard was pushing a bit hard on my computer. I could feel it heating up, and then it left me. So this is 1 second. So I was just saying that if maybe my colleagues can mute themselves so I can not hear an echo, that would be great. So what I was saying so far is really talking about this infrastructure approach, right, whereby you manage to build everything together, as Malte just said, because it's not a given absolutely that you can reach that point whatsoever. Finishing on what the main concerns are for hydrogen financiers and hydrogen investors at large. What we're seeing here is that merchant and offtake risks are the big banks' concerns. So understanding really whether there is a market for that and whether the technology is going to be adopted, but also for some reason banks have high expectations and they hope that hydrogen will get there. Like according to their projections, they have very good expectations both for hydrogen and carbon capture usage and storage in terms of returns, to the point where they think that by 2035 there's a 35% of the interviewed people in the study that we are presenting think that it will outperform renewable energy returns. So we'll see also how that plays out. Of course, these are mostly speculations, but perceived risks versus opportunities seem to show opportunities more on the 2030 to 35 kind of timeline. And lastly, there's a couple of effectively financed projects. One is a large project that France financed in the French Guiana, mitigating risks in this area to get financiers on board. This is a project that shows how having people that already since the very beginning and projects since the very beginning are supported and in collaboration with contractors, but also potential financiers, can yield results. So this is the one to the left is a plant in West Guyana, and it's a joint structure whereby they produced the solar panel fields, and at the same time hydrogen production storage. And this was done in collaboration with the state utility EDF and as well private financial actors. And the other one, NEOM Green Hydrogen Project, is being currently produced in Saudi Arabia. So people can potentially disagree about the need to have this city in the desert, but that's probably another story. But the story here is that it's an area which can lend itself quite easily to production of solar energy and therefore storage through hydrogen. Lastly, we've gone through them several times now. There's blended structures in the EPCEIs because the collaboration between the EU national member states and private companies, that's absolutely one of the ways to go, also for the Commission. But there can be at the city level different levels of participation of projects and municipalities for the creation of this. This is just sort of like a ladder to the least to the most involvement than a city and a private sector actor can have. And lastly, I'll leave you with ideas on DFIs and blended finance solutions, financing green hydrogen economy. This can happen both at the state level, but also at the city level. This report published last year really stressed the importance of having also the contribution on top of states, the EU and private sector, of having also development finance, especially in a non-EU setting, but also in EU. Why not? Of having combination of concessionary, blended, and innovative financing mechanisms to allow faster rollout of green hydrogen. And here it's really like advocating for a combination of all the tools and financing tools to deploy in this sense, whether it's guarantees, whether it's insurance, and all of that. All right, so I'd say if there's any question in particular, I'll be happy to take them. Otherwise, my colleagues, I'm sure, are also happy to take some of them.
Yeah, sure. So thank you, Tommaso, for those last few slides. I do actually have a question starting for you, Tommaso. So you painted this picture of the IPCEIs, right? These huge two projects, right? So high to tech and high to, I think, use, right?
Yeah.
So is there any way, what is the connection with cities? Is there any way of cities to get involved or to be involved? Because it's coming from 15 member states. It's primarily sort of companies involved developing tech, if you like. But I suppose those companies also need sort of test areas and see where it can be applied. And is there any way of cities being involved, or phrased differently, are there cities involved from which other cities can learn?
Absolutely. Yeah. So I would say this is a program that was approved last year. So we're talking about 2022, and it has quite a long-term implementation window, right? So from that, what was mentioned also is the fact that we need to establish a merchant market. So having the potential to have users, right? Because without that, this doesn't really happen. And in particular, if we're talking about the three case that, like the three main uses that we mentioned, cities will definitely be a terrain for implementations, like the city of Bydgoszcz, of seeing whether it's functional, whether it's cost effective to have these buses, to have these long haul transportation. So this is number one. I would say terrain for the implementation of this. But I would say that so like it gets there after a certain period um, of, uh, of of deployment of this tool. The presence of large corporates will then also connect the corporate to their territory. So since hydrogen, as we know, it's not the easiest thing to transport, these are all of these projects are very local in a sense. They're very connected to the territory. So wherever they're being deployed, wherever there's like the large renewable energy project and in local hydrogen production, there will be where that will be used and mostly the market deployed, rather than having a single place where producing hydrogen and moving it everywhere else. So I'll say that everywhere where these companies are located and based will sort of like be the terrain for implementation, and cities can absolutely and will get involved in that.
Because I did see indeed, I was looking for a Polish flag actually on one of the. I think that I saw one and also quite a few Dutch flags as well. A follow-up question for you, Tommaso. So, what would be your recommendation for cities how to facilitate? Well, you presented sort of three viable use cases for hydrogen, or so for storage, transport, heavy duty transport storage, as well industrial use, if you like. So, what could cities do to help accelerate, take up of those use cases in their own, within the city boundaries, basically?
Absolutely. The last case studies, I'd say, they show the importance of having this stakeholder collaboration and building the supply chain together, right, since the beginning. So when there is an idea for a new hydrogen project, the municipality or cities have a very focal position because they kind of have access both to direct contact with corporations, but also to the final end users that will potentially be the ones that receive and have connection with hydrogen. What cities can do, I would say, is starting and being I wouldn't say coordinators, but facilitators potentially of these talks when we are preparing to move forward with an hydrogen project. If the city is the facilitator, it can already plan ahead the locations because the city has access to the land, right? The location, it can have a facilitated contact also with financiers because depending on the track record of the city, a larger entity can have an easier access to finance in that sense, and also it can have quite a leeway towards the final consumption and usage. So knowing that the hydrogen produced in a certain area of the city will then be deployed to power transportation or something else. So really, I think this kind of coordination work is fundamental before even talking about the actual financing. It's really like preparing for that and preparing the coordination and the market in an ecosystem kind of way.
Thank you, Tommaso. And I want to turn to Hannah, actually. When you were presenting, Hannah, I was really intrigued by, so where did you get the inspiration from to start up your hydrogen project? Or you were mentioning, okay, you were involved in the My Smart Life project. You were a follower or fellow city, rather. You have been sort of exploring, looking at even into the city of Hamburg. So you really went out to see, to find inspiration. That's at least what I understood from your story. So how did you find your inspiration, and how did you tap into the knowledge actually to develop your investment plan, and what could other cities learn from that? Because I think you're a good example of making the right connections with the right cities and be involved in this ecosystem of European projects, if you like, to learn and then start up your own project. So maybe Hannah, you can sort of tell the story a bit, so the background story, so to say.
Yes, it certainly the result is participation in European projects because they are ahead. The European cities they are that we have to admit that they are ahead with the technology and application, and the My Smart Life project was inspiration because we could see the investments, and we saw the hydrogen installation for buses in Hamburg, and also I think in the building that the hydrogen is mixed with other gas. It's still not maybe financially reasonable, but I mean about hydrogen in this housing area. But I think that was the start to see already existing installation and something that already works. Another maybe reason was that we did not implement electric buses in the city because when we had a climate plan, CCAP, and we wanted to reach this 40% goal for reducing CO2, then we realized that we had so many buildings that needs retrofitting that for the same amount of money, we can reach a higher level of goal for the CO2 reduction, putting the same amount of money than to buy electric buses and save CO2. So I think that then we thought that maybe it's good for us that we just try to look for hydrogen option, but for sure the international cooperation, being in a networks and learning was the motivation. Yes.
Great, thank you very much, Hannah. So then maybe for colleagues at DNV, we all know internally in DNV there's lots of discussions, electrons versus molecules. That's sort of maybe a sort of artificial sort of dichotomy, if you like. You were sort of showing this, Malte, you were showing this picture of this European backbone. So when will that be there? Will it be there? And what will that unlock? Because clearly around that backbone, you have lots of European cities who could then benefit from actually implementing the use cases that Tommaso was sketching. Because Tommaso was painting a picture that much of the hydrogen is local. It's hard to distribute, but then if you would have that European backbone, that's so some of that sort of negativity would be void, would go away, right? So is that a 2050 story, or what is it, or is it when will we see it? What's your take on that?
I think in terms of what the research currently shows and the plans, it's pretty nicely mapped out actually in the European Hydrogen Backbone map that you can also look up in the internet. That says basically by 2030, I think the first plans would look like first lines going from Northern Africa towards Southern Europe, possibly a line from Ukraine towards Eastern Europe. But there's, of course, still quite an uncertainty given the current situation, whether that's going to be realized in time. But that would certainly unlock potential, of course, in terms of hydrogen imports. And then looking more further into Europe itself, there would be, I think also what we see concrete plans in terms of reusing natural gas pipelines for hydrogen transport. However, that's a bit of a chicken and egg thing as well in terms of either being the infrastructure first in place or having actual production capacities ramped up to the required degree. And again, that's also something that, for example, industry observes, where they're looking into, okay, would like to implement hydrogen, for example, for high temperature applications. But we, on the one hand, don't really know where can we get the hydrogen from. On the other hand, there's quite uncertainty about connections of infrastructure to the location. So I think what we currently see is more on a demo scale applications for green hydrogen. Of course, for conventional hydrogen systems, that's already quite largely in place, but mostly in the current systems on site. So then industry or would have a big steam methane reformer connected to the natural gas grid producing. Certainly something interesting for to see this coming up for green hydrogen as well in the near future. But probably my colleague Joachim has also a take on that. Sorry, Joachim, are you in terms of the hydrogen backbone? You're muted at the moment.
Sorry. Yeah, still muted. No, I think most of the important takeaways you already provided.
Okay.
Well, then I want to thank all of you, all of the speakers for presenting like a technical perspective, an experiential perspective from the city from City Hall, basically, and then also a financial perspective. I think those three perspectives together should help the audience actually, considering to prepare a project proposal to feed into our matchmaking funnel, because that's the whole purpose of this session, to consider, is hydrogen something that we could develop a project proposal around, and then could we then submit that proposal to the Smart Cities Marketplace for consideration. So I want to thank all of the speakers. I want to thank the audience for their attention, and I want to ask the organizers to put up a slide that gives you some information on how to stay in touch with the Smart Cities Marketplace as well. So we have, as you can see, a number of channels, if you like, from X, or Twitter, former Twitter, LinkedIn, YouTube. We have email, we have the website, and so we have lots of channels you can sort of get connected or stay connected. And there's also a specific email address that's being tracked by the matchmaking teams. It's matchmaking@smartcitiesmarketplace.eu. If you send a message there, then you will be contacted by the matchmaking team in response. So do reach out to us and stay in touch. With that, I'd like to thank you for your attention. Thank you very much.